All right, guys. So we're going to continue talking about scatter plots today. In a sense, we're going to talk about the correlation coefficient. Whether you know it or not, we've been talking about this for a while. The R value that we've been getting when we're putting our data in the table, that's the correlation coefficient. So that's a very important term to remember. We probably won't ask you for the R value. We're going to be asking you for the correlation coefficient. So be careful and remember that word. Now, we've been looking at R for a couple of weeks now. We've been using our calculators to find equations. And we already know that if we have an R value of 1 or negative 1, it means that we have data that's linear. So I'm going to say that the data is linear. So again, negative 1 or 1 means we have linear data. Now, if we didn't get 1 or negative 1 in the past, we've said there is no equation. Well, today we're going to talk about what happens if it isn't 1 or negative 1. If the R value falls somewhere between 1 and negative 1, this means that the data is not linear. What it does mean is that our data is a scatter plot. So it is a scatter plot. So now we can kind of use our 1 and negative 1 to tell how our lines of best fit will work with our equations. The nearer R is to 1 or negative 1, the more closely the data clusters around the line of best fit. The other day when we were looking at some of these scatter plots, there were some of them we drew our line of best fit and it almost hit every point. Those would be closer to 1 or negative 1. The ones where there were just a lot of points around but we kind of had a line of best fit, those are getting further away. The ones that had no correlation at all, they would be at 0 if we put them in our calculator. The other thing you want to remember is that if we're closer to positive 1 or in the positive region, we're going to have a positive slope. If we're near to negative 1 in the negative region, we're going to have a negative slope. There's a little chart right below this that kind of says the same thing. If we get a 0, that means there's no correlation at all. They're just random points. The closer we get to negative 1, the stronger the correlation is, and the slope would be negative. The closer we get to positive 1, the stronger the correlation is, and the slope would be positive. So let's move down the page just a little bit, and let's look at an example. The table below shows the weight of a panda as it ages. So it gives us age and weight, and we're going to put these in our calculator in the stat function. We're going to call our age L1. Those are our X values, our independent variables. We're going to put our weight or Y values in L2. Those are also our dependent variables. So it looks like the weight depends on the age of the panda bear. So we need to put this in our calculator, guys. Remember, go to Stat and Edit. L1's your age, L2's your weight. Then after that, push Stat again. Go to the right to Calc and go down to 4 and hit Enter twice. And it'll give you the Y equals AX plus B, the A, the B, the R squared, and the R. So remember, we are looking for the correlation coefficient. And remember, that is our R value. It's not capital R, it's lowercase r. So all I want out of this is the R value. If you got it, you should have gotten 0.9967. Now, we want to kind of figure out what kind of correlation we have and how strong it is. Well, the first thing is, are we in the positive or the negatives? Well, we are in the positive, so it's going to be a positive correlation. But we also want to tell how strong it is. Well, 0.9967 is really close to 1, so we have a pretty strong correlation. Okay? So that's really not that bad. Remember to put it in your calculator correctly. There are a lot of decimals in some of these. You have to be really careful when you put those in your calculator, because if you put in 54.9 or if you put in 549 instead of 54.9, it's going to really affect your answer, so be careful there. Now, if we come down a little bit, we're going to learn 2 new vocabulary words: association versus causation. How strong of a correlation something has can also help us determine if we have an association or a causation going on. A causation means that a change in one quantity causes a change in another. It would be like maybe if I stopped going on a diet and I ate more fatty foods every day, that would cause my weight to go up, so it directly affected the other quantity. Association means that they could have a correlation and be associated, but that one does not cause the other to happen. So we're going to look at the next page at a few examples and see how these work. So it says, consider the following examples. We're going to try to tell what kind of correlation they have and if they have causation, association, or maybe neither. So the first one, A, says the number of loaves of bread baked and the amount of flour used. Now, when you think about the number of loaves baked, you would have to have more flour if you're going to make more loaves. So these two are absolutely causation. The more more loaves of bread we make, the more flour we are going to need. Now we want to think about if it's positive or negative. Well, if we need more flour to make more bread, then we're getting bigger, so we have a positive. So these can be kind of tricky, you really have to think about it. It says the number of mailboxes and the number of firefighters. Now, that might not seem to be two really interconnected things, but the more mailboxes you have means the higher population, and the higher population you have means you have more firefighters. So they're sort of associated, but they're sort of not. So this one is an association. Remember, association means they could have a correlation and be associated, but that one does not cause the other to happen. Just because you have mailboxes doesn't mean you have firefighters, but in a way, the more mailboxes you have, the bigger your population. Now, the more mailboxes you have gives us more firefighters, so that would be a positive correlation. Okay. The next one, the shoe size and a salary of a teacher. Well, I don't think that anybody's shoe size determines their salary. There's teachers here who probably have small shoe sizes that have been here for 20 years that make a lot more money than Mr. Clevenger, who's been here for 1 year, and I have fairly large shoes, so I'm going to say that it's neither causation or association, it's neither. And just like when we did the scatter plots and decided if they were positive, negative, or no correlation, shoe size and salary have nothing to do with each other, so there is no correlation. So think about if things can associate or not. The last one, D, says the price of hamburger at a grocery store and the amount of hamburgers sold. Now you kind of have to think about this. Would the price of hamburger have to go up for more hamburgers to be sold or down for more hamburgers to be sold? Generally, when the price goes down, you're going to sell more of your product. So instead of having a positive correlation, we're going to have a negative correlation. Because as the price drops, we're going to have more sales. Now we need to think about causation and association. Is the price dropping going to cause more hamburgers to be sold? Well, yes, it is. So that would be a causation. Now, if you've got someone around you, some of you may be watching this at home, some of you may have other students with you. It says discuss with a partner what types of correlation these examples are likely to have and if they would fall into causation or category or association. These are not the easiest things to do, and sometimes you may not realize why we put the answers we did. You might want to talk to somebody else. Talking it out sometimes can make this stuff a lot easier. So guys, we are going to have a quiz on this on Friday. I hope this helps out a little bit. If you have questions, which I can understand, this is kind of confusing, you need to come talk to me in class. So good luck.